Welcome back to the solutions manual. In this video, we will solve the problem 2-65 from RC Hibbeler Engineering Statics 12th edition. According to this problem, the two forces F1 and F2 acting at A have a resultant force of 100 lbs directed in the negative z-axis. We have to determine the magnitude and coordinate direction angles of the force F2. To solve this problem, first of all, we have to express each of the forces into the Cartesian vector form. So starting from the force F1, first of all, I have to draw its projection on the xy plane, and the projection would look something like this. Let me label it. So this right here is F1 cos 50. Now I have to resolve this projection along the x and the y axis. So this is the component along the x axis, and this right here is the component along the y axis. So let me adjust it a little bit. Yeah, that's fine. So let me label them as well. So this right here is F1 cos 50 into cos 30, and the y component is F1 cos 50 into sin 30. I have one more force component of the F1 force, which is directed in the negative z-axis. So this is the component along the negative z-axis, and this right here is F1 sin 50. So F1 force in terms of Cartesian vector form can be written as negative F1 cos 50 into cos 30. And why it's negative? Because it is acting in the negative direction. So negative F1 cos 50 into cos 30i plus F1 cos 50 into sin 30j minus F1 sin 50k. So if I substitute the value of the F1, which is 60 lb, so it would be negative 60 into cos 50 into cos 30i plus 60 into cos 50 into sin 30j minus 60 into sin 50k. And if I simplify it, it would become negative 33.4i plus 19.29j minus 45.96k. Similarly, for the F2 force in terms of Cartesian vector form can be written as by using the coordinate direction angles. So I have F2 cos alpha I plus F2 cos beta j plus F2 cos gamma k, where alpha, beta and gamma are, this angle is alpha, which is between the tail of the x-axis, positive x-axis, and the force vector F2. This angle is beta, which is between the tail of the positive y-axis and the force vector F2. And this angle is gamma, which is in between the tail of the positive z-axis and the force vector F2. We also know that the resultant force Fr is equals to the vector sum of F1 and the F2 forces, which is equals to 0i plus 0j minus 100k. So let's call this equation A. So if I substitute the values of F1 and F2 into the equation A, the equation A would become we have negative 33.4i plus 19.29j minus 45.96k plus F2 force, which is F2 cos alpha I plus F2 cos beta j plus F2 cos gamma k equals to 0i plus 0j minus 100k. So now if we compare the I, j and k components, so comparing I, j and k components, for I components we have negative 33.4 plus F2 cos alpha equals to 0. And if I rearrange it, I would have F2 cos alpha equals to 33.4. Let's call this equation 1. For the j components, we have 19.29 plus F2 cos beta equals to 0. And if I rearrange it, I would have F2 cos beta equals to negative 19.29. Let's call this equation 2. For k components, we have negative 45.96 plus F2 cos gamma equals to negative 100. And if I rearrange it, I would have F2 cos gamma equals to negative 54.04. Let's call this equation 3. Now to calculate the magnitude of the force F2, we can use the Pythagoras theorem. So we have magnitude of the force F2 is equals to F2x squared plus F2y squared plus F2z squared. So this is the F2x, this is F2y, and this right here is the F2z. So if I substitute the values, I would have square root of 33.4 squared plus negative 19.29 squared plus negative 54.04 squared. So upon simplification, the magnitude of the F2 force comes out to be 66.4 lbs. So this is our first answer. Now to find the values of the coordinate direction angles, we have to refer back to our equations 1, 2 and 3. So from equation 1, if I rearrange it, I would have cos alpha is equals to 33.4 divided by the magnitude of the F2 force, which is 66.4. So alpha is equals to, if you take the cos inverse of this value, then the alpha comes out to be 59.8 degrees. And from equation 2, cos beta is equals to negative 19.29 divided by the magnitude of the F2 force, which is 66.4. So if you take the cos inverse of this value, then the beta comes out to be 106.9 degrees. And from equation 3, we have cos gamma is equals to negative 54.04 divided by the magnitude of the F2 force, which is 66.4. So again, if you take the cos inverse of this value, then the gamma comes out to be 144.5 degrees. So this is our second answer. So this is it for this problem. I hope you would find this video helpful. If you do, please make sure to subscribe to this channel and also turn on the bell icon for the daily updates. And if you have any questions or any doubts, then feel free to ask in the comment section and I will answer it as soon as possible. Thank you.